Okay, let's continue example C over here. Yeah. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. Okay? So, yes, when you go to grocery stores, do you buy soda every now and then? Yes. Yes. When I look at those 2 liter bottles, yes, you see sometimes a little more, a little less. There are some fluctuations over there. So we can say that okay, there is a standard deviation. Well, that is the larger standard deviation is what? The more fluctuation from one bottle to another. Well, that one is for number one that I mean, in soda case, it's not a really big deal, maybe. Okay, I do not know, but the real cost for them. But for the wine, especially if that wine is an expensive one, well, they would just concerned about the amount they give or they put in a bottle, okay? And number two, when you see like a lot of fluctuation, in some sense, just instantly you have some kind of a little, as you guys are not trustworthy or some kind of feeling like that. Well, I see that way. Well, you guys are not very precise. So that means when you apply the formula, are you precise on that? Or any kind of, just different feelings, they don't want to do that. So anyhow, they want to be as accurate as possible that this bottle of wine contains 250 milliliters. That means they really want to be that way. That means the smaller standard deviation is more accurate in terms of the amount of wine in each bottle. So here it is. So obviously, the old manufacturing process provided what? The standard deviation was 2.323 ounces. So now the wine factory, they reinstalled the new equipment. After this new equipment, the quality control manager believes that the standard deviation has decreased. So that means what? The accuracy in terms of the volume of wine in each bottle has increased. That's what they're thinking. Okay, the quality control manager thinks. So the two previous example was like old data, right? 2008, 2006, old data. Well, in this case, well, it doesn't have to be too old. The thing is what? Timeline is before the equipment or after the equipment. Okay? Anyhow, one party is old, the other party is new. The old party is this. Okay? Old, status of quo, no change. Well, that one is the null hypothesis. And the null hypothesis always use equality over here. So this is regarding what? Regarding standard deviation. So standard deviation, what's the symbol? Yes, sigma for the standard deviation of population. In this case, the population is what? Those wine bottles produced in this wine factory. Okay, that would be the population. But they would be like thousands of bottles. Yes. Okay. So H naught is old data. Before the equipment, that is old one, right? Before the equipment. So H naught is regarding sigma. So this sigma says 0.23 fluid ounces. Yes, this is the null hypothesis. Okay? And the quality control manager believes now, well, we are more accurate in putting the wine in the bottle. So H naught is challenging. This is a new thing so that the quality control manager will gather evidence to support the claim over here. So what is the claim? Sigma is decreased, so less than 0.23 over here. So this is the alternative hypothesis. So what kind of testing are we going to use? Well, you remember those, whether that is Z standard normal distribution curve or student t-value distribution. Anyhow, this is going to be over here. Well, I'm not going to get into that. So here is 0.23 over here. Sigma is less, so you are looking at this direction, correct? So it has to be, a tail is going to be to the left over here. So this is left-tailed test. Okay, so right-tailed, left-tailed, depending on, yes, this new characteristic, okay? New characteristic is a sigma over here. Sigma is less than old data, and then you are going to choose left-tailed test. If that is greater, right-tailed test, and this is simply unequal to this old data, okay? Unequal to old data. In that case, you have to do two-sided tail, to the right and to the left. Okay? So this is a concept. And again, we are going to think about all possibilities that we can face after this hypothesis testing. Okay, so here we go. So this is a reality over here, and this is our conclusion. We can come up with four different conclusions over here. That is, well, we are doing about H naught and H1. So H naught is true. And in this case, H1 is true. Well, only one way or another, okay? No other case. All right. The next one is, we do not reject H naught. I wish we can speak a little shorter, okay? We accept H naught, but again, what? We cannot say that way, okay? We do not reject H naught, and we do reject H naught. And H naught is true, and we do not reject H naught, so that's fine. That is a correct conclusion over here. And over here, H1 is true, and we do not reject H naught. So in this case is what? As the quality control manager said, this sigma standard deviation is less than 0.23. That is a true case. However, we could not gather that part of the evidence sufficiently enough that we do not reject H naught. Well, that is a mistake, okay? So this is error, and this is called type 2 error. Okay, again, type 2 error is made when H1 is true, but we still hold on to H naught. You know what I mean? Okay? And over here is H1 is true, then that in that case we rejected H naught. Okay, then we did the right thing. So that is a correct conclusion. And this case is that H naught is true. Well, still the standard deviation is 0.23 ounces, but somehow this quality control manager showed something that, okay, based on his evidence or her evidence, that we reject H naught. Okay, so we reject H naught. So even though this is true, we rejected it. Okay. We call this type 1 error. Okay, so type 1 error is the probability is denoted by alpha, and this is for beta. And the alpha and beta, the relation is if alpha goes up, this type, the probability that type 1 error, making type 1 error goes up, that means the beta goes down because only one way or another, okay? So this alpha goes down, that means beta goes up like that, okay? And what else? Just for each one, just so you understand that which one goes to null hypothesis and which one goes to alternative hypothesis, which is H1. So just regard this way, always old one, the previous one, or before this equipment, okay, or before this kind of testing, okay, or before the new administration comes, okay. Then get case, many times you see that the new ownership, they talk about new ownership, yeah. So before the new ownership, after the new ownership. Anyhow, there is a split line for the timeline over here, okay. To use that timeline, the old one is the statement that to be tested, okay. That is H naught, as we always use equality over here. Based on the statement is going to be about proportion, about standard deviation, about mean, okay, they could be different, but always equal sign over here. The alternative hypothesis is the researcher claims this, or principal, the one, the new ownership claims this. We improved our taste, okay, or we improved the quality of this material. Things like that. So this one is the new one that's challenging H naught. Okay? And for this case, we may use unequal sign, or less than, or greater than. We do not use less than or equal to. In other words, because equal sign is assigned over there. Okay? That's why we cannot do it. Only these three possibilities. So after going through these three examples, are you okay with that? Okay? So the most important thing as you read the statement, first figure out is regarding what? Mu, P, sigma. Okay? And then once you read it, what is H naught? What is H1? And what is going to be your conclusion? There are all four possibilities I listed over here. Okay? These are all possible possibilities, but what you are going to do is going to be just one of those. Okay, each time you are going to arrive in just one of those four cases. Okay, all right, then we are going to study next one, and then I understand that this part is always difficult to kind of deliver the material, okay, and I have to do it just without real audience over here, without even looking at you guys. I'm just looking at this camcorder lens, you know, it is a little bit awkward. So I kind of, I don't know, it's kind of an awkward situation, okay, but we are going to overcome that. But fortunately, you guys had a good exam 2 score, and just now all you worry about is just a weekly quiz. Well, I noticed that some of you didn't take a weekly quiz last time, but again, we go on as if we met in the classroom, okay? So we have homework every time, and we do have weekly quizzes, all right? And the final exam, as I said in Canvas announcement, and yes, whenever you receive notification from Canvas announcement, yeah, I try to really announce important things. So read the remaining schedule, and you are going to finish the whole thing before the real published schedule in the beginning of the semester. Okay, so we don't have to follow the university final exam schedule. That's why I picked up date early, just as soon as we conclude our instruction. And I'm going to put up the work on my math lab or my stat lab, and you have a couple of days to time span. Okay, you are going to find the quiet time and the good Wi-Fi condition. Yes, I hear sometimes, you know, my Wi-Fi didn't work well, things like that. So find a good place to do your work, and I want you to have a very, very successful semester. Okay? All right. Bye.